Cool. Okay. So, Daniel, your talk is using codegen to avoid heuristic GraphQL queries. And the heuristic approach to querying a GraphQL API is when you run an operation on an API with union or interface types without using a fragment matcher. So this comes with problems, the biggest being the inability to query such an API. So in this talk, we'll look at GraphQL's types, including union types, and look at how the heuristics problem can be solved using codegen. So a bit about you. You are a retired podcaster. You're a Lorde superfan, software developer, technical writer, and currently developer advocate at Strapi. So Daniel, welcome. Thanks so much for doing this, very much kind of last minute. I'll let you take it away. I'm going to pop out and away you go.
Awesome. Thanks. Thank you for the very apt introduction. I am a retired podcaster, a Lorde superfan, and a software engineer. I really just add that bio to take away my nerves before speaking because it's nice to hear and it makes me laugh. All right. So this is the GraphQL logo, of course. And today I'll be speaking about using codegen to avoid heuristic GraphQL queries. It's a bit of a mouthful. The whole talk, to be honest, is a bit of a mouthful, but I'm hoping I've made it palpable enough for everyone to understand. There'll be a bit of a story, so I'm hoping that'll keep everybody engaged. A bit about myself, besides everything that Ryan just shared, I am Daniel Phiri, and you can catch me anywhere online as Malgamves. I do developer relations at a really cool, I'm biased, I would say the best headless CMS, open source headless CMS called Strapi, and I'm a disc jockey on Mixcloud, so if you like techno or Afro House, you can catch me there. All right, that's it. So a bit of an overview as we go through this talk. I'll be looking at the funky error message that inspired this talk. We'll be looking at what exactly the heuristic approach is. We'll be looking at GraphQL union types, a very general overview of them. We'll be going through querying union types and then using codegen. And then, as of a few months ago, there are alternative solutions. So we'll be looking at what those look like. All right. Try not to talk too much, though. I'll sip water to pace myself. So my goal with this talk is to make the hardest thing about union types the spelling of heuristic. So when you think about querying union types, you shouldn't think about how hard it is. After this talk, the only thing that should be hard should be pronouncing heuristic. That was a terrible joke, but anyway, I had to add it. So my funky error message. So story time, I was doing the things with GraphQL, building a web application with Nuxt and Strapi, and I got this message. And at this point, I'd used GraphQL for about 2 years. I had never seen a message like this, and there was a small part of me that was super happy because I was like, okay, what new realm of GraphQL have I entered? But like the larger part of me was, what the heck? I have no idea what's going on. So the error message said, you are using the simple heuristic fragment matcher, but your queries contain union or interface types. Apollo client will not be able to accurately map fragments. To make this error go away, use the introspection matcher. I think this is a really good error message, by the way, because it tells you exactly what's wrong and it tells you how to solve it. So I did just that. I Googled it and something came up. It wasn't very happy. It was really just docs and it wasn't as well explained as I wanted it to be. And besides a few Medium articles behind a paywall, nothing really told me how to solve this problem. Yeah, so that's really what led to this talk. I know what you're thinking. How did you get here? Like, where do you even find union types? I know I was thinking, like, what are union types? And this really led me down a whole rabbit hole of figuring out union types. I mean, I knew GraphQL had union types, but I had never actually used them in a application. So this was very fun to go through and discover. So spoilers, not really spoilers, I was going to tell you either way, but I was using something called Strapi dynamic zones. And let me see if I can actually do like a quick demo, but this is basically a dynamic zone. I think the demo would make more sense. Let me just switch. Sorry about that. I ruined Ryan's screen. I should have asked him first. I need to make sure. Okay. There we go. So this is a section inside the Strapi admin where we can sort of dynamically add content to or different components to pages. So I have three components here: a quote component, image component, and a rich text component. And I can sort of like dynamically add these to web pages without having to rebuild. So to have a look at this, we'll actually go to this about page. So this is in production on Netlify, and it has this really cute image that says Strapi saved my life. So with dynamic zones, if I want to add any more content on this page, I don't necessarily have to rebuild, or like as a developer, I don't have to write any code to have the content displayed here. All I have to do is actually just enter the data in my Strapi console, which is what you're looking at right now. So let's pick an image real quick. I'm trying to keep so let's say Strapi and chill. And chill. So if we save this, this will be added to our page immediately without actually, oh, did I add that to the right page? I think I added that to another page. Let's look at the other pages. We should see Strapi and chill somewhere. There we go, Strapi and chill. So we added it to this page. And yeah, that's really what dynamic zones do. So whenever you want to add data, you really have like a bunch of components that you can choose from. And yeah, that's my very quick demo. I'm happy I got through it that quick. I will stop sharing my screen again. And then I will go back to my slides. There we go. So that was what Strapi dynamic zones are. You basically pick up components that you can display to add content on your web pages without having to write code to make that content appear. It's this concept really that I call building modular applications, and I gave a talk about this at Jamstack Berlin yesterday. So if you're interested in that, I'll leave some resources. I think the next slide should be a link to resources. So if you want a link to a blog post that I wrote about querying heuristic, using the heuristic approach or solving the heuristic approach, everything is here, bit.ly/strapi-dzone. And yeah, I will leave this at the end for anyone else who wants to have a look. All right, so let's get on with it. So what you're looking at was Strapi, where Strapi dynamic zones. And in Strapi, each dynamic zone is a union type containing components that are defined by whatever you name them, whatever you call them. So in whatever dynamic zone we have, I created a dynamic zone called page zone. And inside that page zone, in the interface, you saw a couple components. So you saw an image component, a quote component, and a rich text component. In the UI, that is how they are represented. But when querying Strapi using GraphQL, the dynamic zone is represented by a union type. And this will make more sense as I go into talking about what union types and what benefits they bring. And then each component in our dynamic zone, these being the query, I think I will go back here just to show you a visual aspect of it. So this is our dynamic zone, and each component in the query, in the dynamic zone, be that the quote, the image, or the rich text, is its own type. So that's a bit of context for how I got myself into this problem, and I'll be telling you more about that. So let's talk about union types. We've already established that querying a Strapi dynamic zone is practically querying a union type. But what is a union type? So union types are an abstract GraphQL type that really just indicates that a field can return more than one object. But the funny thing is, it doesn't define the specific fields that get returned. So it isn't explicit. It isn't sort of like written in stone. Of course, the schema knows that all these things exist, But when you're querying with a client, your client isn't really sure, and that's how the heuristic approach comes up. I'll drop some definitions for like heuristic and what that means. Oops. Sorry about that. I always forget. Today I don't blame myself though. So what happened was I have automatic tab closures after a certain amount of inactivity. So nothing to worry about. I'll just share my screen and move faster. Great. So we're talking about union types. And so the union types return more than one object type, but we aren't really sure because it doesn't really define the specific fields that that object type returns. So what does this mean for us? Looking at our dynamic zone, we have 3 components, and each of these are their own type, all stored in a union type. So our union type, which is an object page zone, has or returns 3 different types. So component image, component quote, and component video. Great. We have established how that looks in our sort of query schema language. And now let's look at how we actually query our union types. So this is how I wish, or this is at least how I tried to query union types. It's definitely wrong for a lot of reasons, and I'll get to those reasons a bit later. It's like from my experience querying GraphQL APIs and not having to query a union type before, this was sort of my attempt, a good attempt at that. Very little was wrong, and I will talk about what that is. So this is the right way to query a union type. And if you look at the query format, we have 3 inline fragments. So each of these types that get returned from the union type are fragments. And to use fragments inside a GraphQL operation, or operation here being either a mutation or a query, we have to use the 3 dots. But then also we remember that we're querying a union type, and because, like I mentioned, with union types, you aren't like the fields aren't specified. So it's really more of what word can I use to describe this? A blind search for whatever we can get back, and that's why we use the conditional on. So so in our query, what we're doing is really just explicitly mentioning that if we receive a component image type, we should return the fields that it contains. And we do the same thing for the quote. We return the field that it contains, and we do the same thing for the video. So this is how our query is formatted. We use the 3 dots because we're dealing with fragments, and we use the on keyword because we sort of chancing it, I like to say, for lack of a better term. And then what this results in is a conditional result based on what is available to us when we make the request. So with the union types, it isn't always explicit that because you've added the 3 dots and the on keyword that you will get back the data that you are requesting. Sometimes your schema or your data changes in either, like, be that in your data source, and the type you are requesting doesn't exist. But doing that is sort of like a safer way of making these queries. And that's the statement. That method of querying, that being using the keywords and the 3 dots for fragments, makes the request conditional depending on what is available to us when we make the request. And then this leads us to talk about the heuristic approach. What is the heuristic approach? So for the query we just looked at, for it to work, your client needs to be able to understand the polymorphic relationship between the page zone interface, and the types that the page zone interface that implement the page zone interface. That being the types that it returns. These types being the components in our dynamic zone. So the component quote, the component image, and the component rich text. So all those are the types that implement the page zone interface, but without telling our client that, hey, um, expect these types when you're querying this API. We wouldn't be able to accurately display and return data. And this is what leads to the heuristic approach, not telling the client to expect certain types or specific types that specific union types that our GraphQL API has would lead to us querying heuristically. And that's exactly what I was doing. I just literally wrote a query, and I did not tell my client to expect all the components that I was using in my dynamic zone. So when that happens, the client has no idea what types implement page zone, and that's my error message. I want to talk about heuristic and just define it. A simple like Google search for heuristic returns this definition: enabling a person, I put client, so enabling a person or a client to discover or learn something for themselves. So if someone has to learn something for themselves, of course, first of all, they are lacking the knowledge. But we're dealing with computers, so computers don't really do anything unless you tell them to do that. So they really want to learn it for themselves, and which is why we use GraphQL codegen. And then that's me getting into the next part of this talk. So we need to use something called an introspection fragment matcher. It's a very long word, and it was mentioned in our error message, which is good, and which is why I mentioned that the error message we got was really good, because it told us exactly what the solution to our problem was. All right, so what does this introspection fragment matcher do? So this lets our Apollo client know in advance what data looks like, what our data looks like, and what types it has. And we'll get a bit deeper into how all this works. So the introspection fragment matcher looks at your schema and then puts out all the possible types. So when you send a query containing union types, your client can confidently return data. So your client now is aware of the types that implement the page zone interface in our specific case. So it knows to expect a component image, it knows to expect a component rich text or a component quote, and thus eliminating the heuristic approach that we were carrying out at the beginning without implementing the introspection fragment matcher. But how do we do this? How do we implement the introspection fragment matcher? We know it solves our problem, but how do we go about adding this to our projects? Easy answer is GraphQL codegen. The devs at the guild built this really cool tool. I've always wanted to use this tool. I never like I'm a fan of using things only when I need to, not just because they look nice and they're shiny. And I'm so happy that I finally got to use one of the tools from the folks at the guild. And yeah, this was really great. So using codegen, GraphQL codegen, codegen for short. To use it, a few things that we actually have to do. So of course, using a JavaScript front end project, I was using Nuxt to be specific. So we have to install a couple of packages, and then we have to create a config file to tell our codegen what exactly to do. And then we need to add a generation script to our package.json so that anytime we want, we can run this script, or we can automate this script when we're deploying to production, or whenever our data changes in our backend or CMS or whatever. And then we need to generate a schema introspection file. So this is the file I talked about, which just like, what's the word? It puts out or prints literally all the types that your schema has, so that your client can search through these types and know and look out for the union types. And then we also need to add the introspection result to our Apollo cache. This way, that's just the Apollo way of working through the heuristic query approach. Great. So we have an idea of what we need to do, and I'll let that sink in for a bit while I sip some water. It's super hot. All right. Hopefully it's sunk in. um, so let's start installing our packages. So the big thing we need to install first is, of course, the GraphQL codegen CLI. We run this command yarn ard -d at GraphQL codegen /CLI. And then we also need to install a, oh gosh, sorry about that. So same problem, or really a problem. My tab just keeps closing on me. I'll be back. All right. I need to remember to turn this off the next time I'm presenting. All right. So where were we? We were talking about implementing codegen. Great, so using codegen. So yeah, I hope this sunk in, and hopefully now my browser will behave. Great, so we installed the following packages. The last package here is a plugin that helps us, that implements like the Fragment Matcher using GraphQL codegen, and I'll get a bit into that. So immediately after installing packages, these are the only packages you need to install. I mean, of course, besides already having Apollo client set up and a whole working GraphQL config for your next application, and yeah, and immediately after installing those packages, you can then set up your config file. You can do that using the CLI, but I prefer to just create a YAML file. Yes, a YAML file. And this is sort of the format. We add a schema endpoint, and then we need to define an output folder. So fragment types.json is exactly where our introspection file will be outputted into. And then we need to define what plugin we want to use. And the fragment matcher would get all types that have fragments and then put these into your introspection file. And that's really all that happens with our config. And then we go into adding a generation script to our package.json so that we can generate all these types when we deploy, or when in our dev environment, either in a production or a development environment. You can tweak this command for your different environments. This was my dev environment, and all I did was make the generate script just so that it runs the GraphQL codegen. And then this command checks your config file, and the config file then tells GraphQL codegen exactly what to do. So using the fragment matcher tells GraphQL codegen to output all like fragments or types that have fragments into your into this file from that API. So that's exactly what happens when we run our generate command, and yeah, to actually generate your introspection file, all you have to do is run yarn generate, and everything happens really quick, and that's always nice to have. And immediately after that, all we have to do is add our introspection result to Apollo cache. So this is my config file for GraphQL. I like to separate my GraphQL config from everything else just because I feel like it's a bit cleaner. So you have a couple of things here. You, of course, import your introspection fragment matcher because that's our four-leaf clover. That's exactly what's helping us do away with the heuristic problem. So we import that from Apollo cache in memory, and then we import our introspection result from the outputted file that we got. So this is our introspection file, a schema introspection file, and we import that. We import that as a like introspection result. And then we use our fragment matcher to add our introspection query result, which is the introspection file that we just imported, and then we add that fragment matcher to our cache so that our Apollo client checks that whenever it makes queries, and so it's aware of the types that that might be coming in, and then really this is the secret sauce into avoiding the heuristic approach. So immediately after we do that, that's it. You have solved the problem of the heuristic approach. Um, as of so that solution happened before Apollo 3 came out, and uh, knowing that, I don't think I could have gone through this talk without mentioning that it's relatively much easier in Apollo 3. And at the time of solving that problem, Apollo 3 was still, I think, in beta, and it wasn't really safe to test in production. So, like I mentioned, everything changed with Apollo 3. And what changed? We have something called possible types. But before we get into that, I really want to abstract all that we've done and talk about what the core solution is. I'm explaining how to solve um, the heuristic approach to querying GraphQL APIs. And in my definition of heuristic, or the Google definition rather, it's really just letting your client figure out for itself what types you have, especially when querying union types, because by definition, union types aren't always explicit with what they can return. So you need to tell your client exactly what to expect so it can accurately and confidently return that data to you. So that was the core problem. You need to tell your client what types to expect. And that we use the introspection fragment matcher to do just that with codegen. Now, with Apollo 3, we have something called possible types. And it's practically the same thing, but bundled into, I guess, Apollo. Yeah, that's exactly what it is. It's the same thing bundled into the Apollo client. So this is sort of their version of creating a schema introspection file. You make a query to your API, and your query really is checking for the schema for the types, the type names, and the possible type names. So that really just sorts out um, the ones that have fragments, and then we return this and eventually store it in a JSON file, just like we did in the solution I just talked about. And this is sort of what I like to call like creating your introspection file, because you're really just getting your schema and storing all the types in a JSON file. And then you're adding your introspection file to your cache. Of course, the config is much less, because all you're doing here is importing possible types from the output folder and adding that to your cache, your in-memory cache. And that solves the problem of heuristic queries. So the whole codegen thing, I think, is a really great way of understanding the problem and building up to the solution and then understanding union types. And I really liked, I think, like I mentioned when I was explaining the error that I got, it was like a good part of me was excited for what I was about to discover, and it led me down this whole path of exploring union types, fragments, and codegen. So that was really nice. But yeah, Apollo has come up with a really cool solution for doing this. I haven't tested this out. I just felt like I should share it. So I'm not really sure. There's probably ways of tweaking it. I'm not really sure how you would do this you probably have to run this every time you build your application so that the possible types file is updated with the newest types from your API. Yeah, so maybe a script to do that at build. Yeah, I think that's pretty much it. I was going to do a demo, but I chose to do that at the beginning. So I already demoed how Strapi dynamic zones work, just to give you context for where exactly I was using these, where exactly this problem was coming from. Not really problem, this opportunity to learn, let's call it that. And yeah, if you didn't catch the link to the resources, this is it, bit.ly/Strapi dzone. And thank you very much for listening.
Awesome, Daniel. Great talk. Thank you so much for doing this. If folks want to get in touch with you, I guess your Twitter is there. That's the best place for them to perhaps follow up with some questions, is it?
Yep, that's the best place.